Good afternoon, boys and girls and Cougar parents. This evening we're going to be looking at converting fractions to decimals and decimals to fractions. And more specifically, converting repeating decimals to fractions. There's a little trick to that, and once you catch on, it's pretty simple. Okay, let's get out our homework and do a couple sample problems together, shall we? Girls, let's start with number 1 from our homework. We'll be converting fractions to decimals first. We know that every fraction is really a division problem. And that's even true with mixed numbers. And here we have the mixed number of 8 and 29 33rds. We're going to focus on the fraction part and just hold off on the whole number. So we have 29 33rds, which we know is really 29 divided by 33. Just think of the fraction bar as a division sign. So 29, our numerator, goes in the house. 33 goes outside. 33 will not go into 29, so we're going to treat 29 as 290. And 33 will go into 290 approximately 8 times. Okay? 8 goes, or let's see, 8 times 3 is 24. Carry the 2. 8 times 3 is 24. Plus the 2 is 26. I subtract. Gotta do some regrouping. Okay, the 9 becomes an 8 because I'm borrowing from it. And then the 0 becomes a 10. 10 minus 4 is 6. 8 minus 6 is 2, so I have 26. And I'm going to bring down another 0. And 33 will go into 260. It's got to be 7 times. Okay, because 8 times is 264, so it's a little short here. 7 times 3 is 21. Carry the 2. 7 times 3 is 21 plus the 2 is 23. And I subtract. I have to do some regrouping. The 0 bars from the 6, it becomes a 10. The 6 will become a 5. 10 minus 1 is 9. 5 minus 3 is 2, and I bring down another 0, and I think I see a pattern here. Okay, I get 290, which is going to be the same number that I start out with, so I can see that it's going to be 87 hundredths, and that'll be a repeating decimal. But don't forget about the 8. I got to put that 8 back in there, so it's 8 and 87 hundredths as a repeating decimal. Okay, the next type of problem we have, if we go down to changing decimals to fractions, first of all, just regular decimals, terminating decimals are extremely, ridiculously easy. All you have to do is read the decimal correctly. Okay, when I look at number 10 here, I have 5 and 56 hundredths. Did I say a fraction or did I say a decimal? I said both. I said 5 and 56 hundredths. Okay, I read it properly. There you go. Now, the only thing you might want to do is often it'll ask you to reduce your fraction and put it in simplest form. Now, I see 56 hundredths. I know that I can factor out 2. I can divide this by 2 over 2, which would then give me, oh, this would be 25, 28 fiftieths. And I can factor out another 2 out of both the numerator and denominator, and that would give me 28 divided by 2 is 14, and 50 divided by 2 is 25, and I think I'm done, so I would get 5 and 14 25ths. So there was a little bit of work there reducing it, but our first answer, 5 and 56 hundredths, mathematically that is accurate. We just want to simplify or reduce it. The same is true with number 12. Just read it properly. This is 75 what? Hundredths. Hey, there we go. 75 hundredths. It's that simple. Now, I see 75 and 100. I think 75 cents and a dollar. And I know that I can divide both of these by 25 because I'm just thinking quarters here. 75 divided by 25 is 3. And 100 divided by 25 is 4. My answer in reduced form is 3/4. Okay, now here comes the tricky part, which hopefully is not too tricky, but we've got repeating decimals to fractions. Okay, the first thing we need to do is we need to set up a simple equation. We're going to say that number 6 here is 45 hundredths repeating decimal, so that 45 hundredths keeps on repeating. So we're going to say x is equal to 4,500 repeating decimal. And what does that mean? That simply means that it's 0.45, 45, 45, 45, and that just keeps on repeating, going on forever and ever. It's a repeating decimal, it doesn't have an end. Okay, well let's count over. We know that if we wanted to get rid of the repeating part, or at least get past that, we would have to move the decimal point 2 places over. So if we multiply x by 100, that would now be 45 and 45 hundredths, which is repeating, keeps on going on. Okay, now here's the trick. We want to get rid of the repeating part. That's the confusing part. And how do we do that? Well, we've got to take away the repeating part, which is x, or 45 hundredths repeating decimal. So x is equal to 45 hundredths repeating decimal forever, right? So let's subtract that. Look what happens. Okay, I get rid of the repeating part. These are going to cancel each other out. They're going to cancel each other out when I subtract, and I'm just left with 45. I can deal with 45. Okay, and then 100x, and if I take away 1x, what am I left with? I'm left with 99x's. Hey, now I have a one-step equation. Okay, and I want to get x all by itself. I want to figure out what this repeating decimal is as a fraction, and sure enough, okay, if I want to get 99x, how do I undo that? I divide it by 99. Okay, I undo multiplication with division, and what I do to one side of the equation, I must do to the other, and there I have it. X is equal to 45 99ths. And if I want to simplify this, which I do, I see that 45 and 99, I can factor a 9 out of both, and I am left with 5/11ths as my final answer in simplest form. Let's take a look at number 7. Okay, same thing here. It looks a little more scary though. I have, it looks like a, well, is that tenths, hundredths, thousands? I have 6 10,000ths. 6 10,000ths. So x is equal to 6 10,000ths repeating decimal. That means that's just going to keep on going on, repeating again and again. What's going to repeat? Okay, it's going to be the 0.0060006, and that's just going to keep on going. Well, we want to try to get a whole number out of this, or a mixed number, so we're going to have to multiply 6 10,000ths by 10,000. So if I had 10,000x, that would be equal to 6 and 0.006 10,000ths repeating decimal. Okay, well, I want to get rid of the repeating decimal part, which I labeled x, so I subtract 6 10,000ths repeating decimal. Okay, I want to get rid of the repeating decimal, so I subtract it, and I'm also going to have to subtract x from 10,000 x's, and what's that going to leave me with? That's going to leave me with 9,999 x's is equal to, well, the repeating decimal part I got rid of, 6. Okay, and now I just want to find out what x is. I just want to find out what x is, this 6 10,000ths repeating decimal in fraction form. So I've got to get rid of the 9,999 x's. Well, I want to divide that out and just have one x. So I divide this side by 9,999, and I do the same thing that this side over here, 9,999. I'm making an equivalent. And when I'm done factoring out all of these, I'm left with x is equal to 6 9,999 ninths. That's a mouthful. Okay, and sure enough, I can factor a 3 out of both the numerator and denominator, and 3 goes into 6 2 times, and 3 goes into 9,999 3,333 times. And that is my ridiculously funky fraction that is equal to the ridiculously funky repeating decimal of 6 and 6 10,000ths. Boys and girls, that wasn't that bad, was it? Okay, and hopefully what we can remember is anytime we're converting a fraction to a decimal, we just have to remember every fraction is a division problem. You simply divide the numerator by the denominator, and that will give you a decimal answer. And when you read a decimal properly, you're also saying a fraction. Okay, so that's easy enough. And I'm sure you got that trick down with converting repeating decimals to fractions. We got to set up an equation, and we just want to get rid of the repeating part, which will leave us with a fraction. Okay, easier said than done. Bye-bye.